107. I think you kind of flip back to that floor plan. I think you kind of know where that is. Server 107 is actually right there. So find a spot for it in there. Obviously, there's going to be a bunch of stuff in there. You're going to have all your server racks for technology, and I think we asked for the fire alarm, the main fire alarm panel maybe to be in there also. Yep. So there's going to be a few things in there. So that's where you want to put your main security panel. Door contacts at exterior doors. Basically, all that is a contact that, if you don't know what that is, it's a contact that when the door is shut, they're closed, and when the door is open, they separate. So we want one of those, a set of those at every exterior door. Motion detectors throughout the corridors. So corridors, I'm gonna kind of give you we want to obviously cover. Wow, cool.
That's okay. Grab an eraser. Just put the pen. Put the pen first. Okay, once it works. Yeah.
Okay, that's not gonna happen again.
Good.
So we're gonna have one at the end of this corridor, probably one at the end of this corridor, and what am I doing wrong here?
Good.
Twice, so it's gonna happen again.
Well, how do I make that not happen, I guess?
Let me see. I think maybe you're too sensitive to it. Let me just see.
I'm too sensitive? Yeah.
Oh, it is. So,
Oh boy.
let me close it. Close it. Get started over here. Okay.
That's better. Yeah. So, motion detectors throughout the corridors. We want to cover each corridor. We also, in between the cubes, I'm going to count that as a corridor. So, but you got to keep in mind that these are cubes. They're not walls that go all the way up. I guess more in here is where that would matter. But we also want to cover each corner of this space in here. So you got motion going that way, motion going that way. And here we got motion going that way, we got motion going that way. And same thing throughout the open office. My interpretation of a corridor, this would be interpreted as a corridor to me, so I want this covered. I don't know where you want to put your sensors, but I want it covered. You could probably put one here and face it that way. As far as coverages for motion detectors, not sure exactly how far they can reach. I'm sure it depends on the model, and that's where you guys kind of got to do a little bit of your own research. So if we go to a simplex system, you go to the Simplex website, find one of their motion detectors. I think they have some that reach 100 feet. So if you want that type of system, 100 feet, if you put one on this wall, it'll reach out all the way over to there. So you should be covered. Glass break sensors. I'm gonna get rid of all these scribbles. Glass break sensors on all exterior perimeter windows. A glass break sensor is something that's also connected to the security system that basically just picks up certain frequencies of glass breaking, and then it sends a signal back to the security panel that that glass is broken in the building. So it says we want them on all exterior windows. Well, if you go, like for an example, this exterior wall right here, if you look at all your architectural elevations, this is all windows right here. But there's probably some some mullions in between that kind of separate them as windows, but really a glass break sensor is sensing a frequency. So we don't need one for each of these windows. We need one for this set of windows. But, so that's one sensor rather than having, 5 sensors along that outside wall there. But you got to figure in this office here, this door might be closed and we might not be able to pick up that same frequency. So we got to have one in this office. We got to have one in this office. Exterior windows kind of going across here. Probably one in the reception area. Then we go back into some closed offices. No windows in the receiving room. Go back around. We have our window cubes here. Same thing. We probably only need one. We got some windows up in here, and same thing here with a bank of windows. So that's kind of all your windows covered that we need with glass break sensors.
And Joe, are these ceiling mounted or wall
Ceiling
mounted?
mounted.
It doesn't matter.
Well, I suppose it doesn't matter. It doesn't specify right here what we want. What we have in the building is ceiling mounted.
Are the doors glass? Entry doors glass?
The front doors are, yes. So probably one in the vestibule wouldn't be a bad idea.
The reason why I'm saying because the family that we have right now is I think it's meant to attach to the wall.
Really?
But I guess we can modify it, or we can just in Revit. We can put it, assume it's going to be in the wall, right at the top of all these.
Motion detectors, I would say on the wall, but glass breaks, I would say on the ceiling.
Okay.
Audible alarm. This.
You can use a different color.
Yeah, all right. Audible alarm is basically just an alarm that if somebody does break in, that they know that the system is in alarm, so they know to get out of there before the cops come, rather than basically it being a silent alarm. We want an audible alarm, and I guess what we have and what we're requesting, you want it to be able to be heard throughout all of the space. They're pretty loud, and there's no real requirement that says it needs to be heard. So what I would say, if I was designing a security system, I would put maybe one for the open office here, and then maybe another one somewhere over here, maybe almost right there. I don't want it to be kind of hidden away over a cube, but something to get that audible alarm out into the open spaces.
Do you have a PA system?
No.
Next project, Chris, we're requiring a PA system, so we have speakers and so forth.
Yep. No, good question, because that's something that can be put through the PA.
We have a phone system too.
Yep.
They have their phone monitor. Push another thing on it.
Yep. Main staff keypad located in main entrance vestibule. So besides the panel that we have in the server room, we also have a keypad, obviously, to disarm the system. So keypad at the main entrance as you walk in. It really doesn't specify, but if you picture yourself coming into this building after hours, you're a hard worker like Nick, and you're coming in on the weekend, and no one is in the building. This door isn't going to be unlocked at all times, so there needs to be an exterior keypad on the outside of the building that Nick can put his code in, and he can enter in the building, and then there needs to be another keypad that disarms the system. So right now, this first keypad, all it does is unlock the doors, unlock these two doors. So you got the right code, you can get in through those two doors. And then what we have right now is another keypad. As soon as you walk in the door, you type in your code there again for a second time, and then the system is disarmed. So kind of number 6, we say main staff keypad and main entrance vestibule. Well, there's if you know, like I said, picture yourself walking into this building. You need to be able to get in the entrance, and you need to be able to disarm the system. So that's really 2 keypads. So you have an exterior keypad that gets you in the doors, disarms the magnetic locks. You get in, and the security system is beeping. It gives you 45 seconds to enter your code, or the system goes into alarm. So, any questions on security system?
When it's armed, does it lock the other exterior doors and do something to prevent them from false trip?
When it's armed, it does lock all of the exterior doors that have that aren't, you know, automatic locks, or the ones that are magnetic lock. The security system automatically grabs that magnet and holds it. But like the receiving door, it has door contacts on it, but it's just always locked and isn't able to be opened from the outside at all. Yeah. Yeah. But if you go to the keypad, just kind of nothing to do with designing, but just for your own reference, if you go to the keypad and, you know, Nick worked 3-4 hours on Sunday, and he's going to arm the system and he's leaving, then he also went out the receiving room door to throw something in the dumpster, and the door didn't shut all the way. Then he goes to arm the system, and it won't let him arm the system because that door is open. So just kind of, Dustin knows all the quirks of the security system. Any other questions on security system?
Is 45 seconds pretty standard?
No, not really. I guess I think our system allows anywhere from between 30 to 120 seconds. Obviously, for different types of occupants, you want different amounts of time. You know, if you have people in wheelchairs that are getting into your space, I think you should give them 120 seconds, because to get in through 2 doors and get situated and get to the keypad to where you can enter your code, you know, you need a little bit more time. So it's not a standard time, no, but most systems allow you different amounts. So. And this is, you know, there's 1,000 different types of security systems out there, and different levels of security. I would recommend, you know, just maybe going to the Simplex site, or the Silent Night is another one, and just looking at their devices. So go into the Silent Night site and look at what they use for door contacts, and look at the wiring diagrams, and look at how they work, and look at what they use for motion detectors, and look at the coverages. You know, I can get one that you can put in the middle of a room, and it can cover all the way around 360 degrees, and it covers 50 feet out. Or I can get one that's meant for a corridor that has a tight beam that shoots down a corridor 100 feet. So there's different coverages that you might want to look at. Same thing for fire alarm, which we'll go over. With fire alarm, it's more of a code-driven thing. With security, I just want to make sure I get my coverage so the building will sense motion at the right spots. So, if there's no other questions, I can move on to fire alarm. Just save all my scribbles.
Let's see. Yeah.
So fire alarm system. This building, though a fire alarm system is not required for this particular building, provide a complete fire alarm system with the following minimum components. Fire alarm requirements. this building is completely sprinkled, meaning there is fire sprinklers throughout the entire building, which because of that, it means that we don't even have to put a fire alarm system in this building. But us as the owner, we are asking for a fire alarm system for this building. So that kind of answers why we're putting a system in that's not required. I'll kind of run through everything same way I did on the security system. If questions come up, I guess ask them right away as I'm talking about it. The main control panel, same type of deal. It's in the server room 107. That's where the main panel is located. Same thing as the security system having a keypad in the vestibule. The annunciator panel is going to be located in the vestibule, which an annunciator panel with a fire alarm system is what the fire department is going to see when they come into your building for the first time. So you've got your main fire alarm panel here, but you also have an annunciator panel, which could be a couple of locations. It could be here or it could be here. But when the fire department gets a fire alarm, the monitoring company calls the fire department, says this building in White Bear Lake is in fire alarm, send the trucks out. So the trucks come out and they're going to come into this entrance. There's either going to be a lockbox on the outside, or they're going to have their own key code access to get in. So they're going to enter through this door, and then they're going to, first thing they're going to do is look at that fire alarm annunciator panel, and it's going to say, with an addressable fire alarm system, which is what we have here, it's going to say that there is a smoke in the lunchroom that is an alarm, because when Nick left after he set the alarm, he left the some toast in the toaster and it started on fire. I don't know, but so it's going to tell the fire department exactly where to go, so they know that they don't need to start searching over here. It's a 10,000 square foot building. It's not that huge. It makes tons of sense in a huge building, and it still does make a little bit of sense in a smaller building like this. But so they know exactly where to go. It's this annunciator panel is telling them where the fire originated from, and especially if it hasn't spread, they can get there right now and put it out. So that's the purpose of having the annunciator panel. It's for the fire department. Manual pull stations at exterior doors. Again, they're not required, and especially with us doing a lot of schools, they used to require them in schools. Now, for obvious reasons, they don't require them in schools because people would pull the fire alarm a lot. In fact, most fire marshals will tell you to get rid of them right now if you have them, because more false alarms in a school means a lot of wasted time for them. So, but in this building, we have responsible adults working here for the most part. So we want fire pull stations at every exterior door. You got one there. You got one there. You got one here. And you probably got one in the receiving room here also. Number 4, audible visual indicating devices throughout common spaces. Audible visual device is a horn strobe device. It has a horn on it. That's obviously the audible part. It has a strobe. That's the visual part. If Chad handed these out, I think there might actually even be a template. I know there's a template in CAD. I don't know if they have a template in Revit or not, but it'd be pretty easy to make one. To lay out your horn strobe so you have complete coverage. It all depends on which candela you specify. Candela is the brightness of the strobe. The horn, obviously noise travels pretty well, so if you have one horn right there, it's gonna, you know, it's gonna be heard all the way throughout that space. But the strobe part of that same device might not cover over here. You need to figure that out when you're laying out your devices. So you need to take this or in CAD or create your own in Revit and lay it out and see your coverage. We want to be able to, we want this complete coverage. If you have a 110 candela device and it only goes out to here, this is your coverage, then you need another device back here to cover that area. And it says audible visual devices throughout common spaces. Closed offices, closed conference rooms, not a common space. Open office, lobby area, the corridors, common spaces, not the receiving room, not the print room, not the server room. No, not the library. Library, I guess that's kind of, it sounds like a common space, library, but really there's not people that aren't familiar with our building coming into our library. Our library is a library that we keep our catalogs for light fixtures and air handling units and everything. And it's not a public library, so it's, yeah. That's a good question. I don't know what I've said in the past years, but I'm going to say yes, because a lunchroom is kind of a common space where a person that's not familiar with the building might be in.
You can say one little thing.
Yep.
I always told them, if in doubt, but one.
Yep.
Then the fire marshal can remove it, but it's really, that's kind of my default. But if in doubt in a space, just throw one.
Mm-hmm.
Better than not having one.
Yep, exactly. Especially with fire alarm, it's something you want to make sure you're covered. So, with fire alarm, occupancies can be kind of tricky. You know, if this building was required to have a fire alarm system and you didn't put one in the lunchroom and the fire marshal came through and he classified that as a public space and you didn't have a horn strobe in there, he might say you can't move into your building until you get this horn strobe in. And you were all set to cut the ribbon and move into your building, and all of a sudden you can't even walk in the door because he puts a no occupancy sticker on your front door. So fire alarm is a sensitive deal, like Chad said. If in doubt, put one in. That's something.
I was wondering about the manual pull stations. Would it be a bad idea to put it in electrical mechanical room?
No, it's not a bad idea at all. We're not requiring it for this, yeah, but it's that's a spot where fires could happen, and if you're in there and you see that fire start, then you would be able to pull that right away. The reason we put them at exterior exits is because most of the time, if you spot a fire, you head to the exit on your way out, you trip that, you pull that. So that's the reason for having them at all the exits. It's not a bad idea to have one in the electrical mechanical room. In schools, I still put them in boiler rooms, even though we don't want them in the public spaces in the school. But in a boiler room, in a big boiler room for a 400,000 square foot high school, if something happens in there and the custodian's the only one in there, he's gonna pull that alarm on the way out. So, good question. Corridors for horn strobes or for pull stations? I think just at the exterior exits. We don't need them throughout the corridors. No.
Joe, don't they have, I think there's something 100 feet. If you're 100 feet or more, you pull them. I can't remember. There was a 72. There's we don't have it in this situation, but if you have a big hallway or corridor, I think every 100 feet, if I remember right,
That rings a bell also, yeah. That's, you need to be, you need to be so far away.
So far away from the pull station, but I don't know if you guys, you removed them from school though.
Yeah.
So it's not an issue anymore.
No, not an issue anymore. So I haven't seen that, and
Okay.
but there is, I'm sure there is spaces
Distances, yeah.
where there could be a gigantic office building where you might be 100 feet from a full station, so you might have one in the middle of a corridor.
Yeah.
For this building, no, we don't. But that could happen. So. Visual indicating devices in toilet rooms and conference rooms. These are spaces that the door is closed a lot in, and the horn part of the audible part of the horn strobe might not blare into. You might be in this conference room, sitting in a conference on a conference call, talking to people, and the fire alarm might go into alarm, and you might not be able to hear that. So what we want is a visual only, a strobe only in the conference rooms. So pretty much, I would say, right as you enter that door there, have a strobe only. Same thing in the restrooms. Doors closed, obviously, and pretty soundproof. So if you got a horn strobe out in the corridor here, it might not reach in there. You need to know that there's an alarm and you need to get out as soon as possible. So strobes in both restrooms. One reason for not putting a horn strobe in restrooms and conference rooms, they're kind of a small space. You get a horn in there, even if it's a low audible horn, it's just so small of a space, you blow your eardrums out running out of that place. So strobe only, visual only. It's something that you will see that flashing light and you'll know to get out of there. So.
Not to mention there's tile and a bunch of.
Yeah, that's it. Yep, exactly. It'll echo. Smoke detection throughout the entire building. Again, not a requirement at all. In fact, a lot of people will try to deter you from doing that because smoke detectors, when they're not required, are just more of a false alarm trigger than anything. Because when they get dirty, after the system's been installed for 10 years, if a building owner isn't maintaining their smokes, they might get dirty and you might get tons of false alarms. And false alarms mean fire trucks, screaming out to your building, and then all of a sudden there's nothing going on, and they go to that annunciator panel. Because we have an addressable fire alarm system, that means it's a smart system. It knows what's going on. They might come in here and it might say dirty smoke detector in mechanical room, and then the fire trucks just came out to your building for nothing. So.
And I think after a certain runs, they start charging people.
Yeah.
Oh, yeah, it's after that.
I don't know if it's once or twice after that. I can't remember how many, but.
Some panels can tell the difference between a smoke detector that's dirty and between one that's an alarm. Most newer systems actually can tell what a dirty smoke detector is. And then it gets a little bit more complicated because some systems are actually even smart enough to know not to call the fire trucks if it's a dirty smoke detector. They just send a supervisory alarm, which the owner would get a call then and say, hey, your system is an alarm, supervisory only, which doesn't mean general alarm, which we didn't dispatch the trucks, but you need to do something because your system's an alarm. So then you, as an owner, would go to the building, walk in the door and see that your annunciator panel says dirty smoke detectors in the mechanical room, and then you need to call for somebody out there, clean that smoke detector and or replace it. So. Smoke detection throughout the entire building. So you need complete smoke coverage throughout the entire building, which means smoke detectors need to be placed to cover this entire open office area. I'm just kind of guessing with coverage here, but I think you also got some coverage. Did you hand those
Yeah,
out? yet?
everybody is.
Okay, so
So
these other simplex ones here for smoke detectors.
We said, I think what we said, there's 30 to 30, if it's a rectangle or a square, or a radius of a circle of 21 feet.
Yeah,
Right?
and 21 feet, it takes into account different different ceiling heights. So it's almost got a little bit of a fudge factor in there. But what I do when I lay out smoke detectors, there's our coverage, and that is 21 feet. The radius. So then you're going to lay out your smokes with these awesome circles around it.
Overlapping, yeah.
Yep, and yeah, like Chad said, they should overlap. If they don't, if you've got this tiny little corner over here that's uncovered, then you either have to shift them or you have to add a smoke. You want them to overlap. You want, and obviously I'm not really drawing the scale here, but you want coverages like this.
Everybody guys got the radius of 21, not diameter, radius?
Yep.
Or 30 by 30, if you're using squares with a pen. That's about it.
And it says throughout entire building, so small rooms, offices, restrooms, mechanical room, lunchroom, everything throughout entire building. This owner is particularly paranoid about fire, so he wants smoke detection throughout the entire building.
Does the ceiling look like a toy store after you're all done with this?
Lots of devices, yeah. It would probably. I mean, but obviously for average Joe doesn't really notice, a smoke detector on a ceiling, a white smoke detector on a white ceiling tile. Might not even notice something like that. So, but yeah, to you and I who look up all the time, there's a lot of stuff on the ceiling when you have smoke detectors and sprinkler heads and everything else that you have mounted on the ceiling. So. Duct smoke detectors. There's one air handling unit for this building. So there's one unit that supplies air to the entire building. What the code says is that if the unit to this building supplies over 2,000 CFM, which a CFM is a measure of how much air it's distributing, then you need a duct smoke detector. I'm going to tell you right now that this building, that one unit does supply more than 2,000 CFM.
Isn't it here somewhere?
Yep.
In the area?
Yep, right about there. Oops. It's not that big though. So it's in the mechanical room. It seems like codes change every year as far as, I guess maybe not every year, but every 5 years or so we have to relook at it because of there's supply ducts and there's return ducts. Supply ducts are what comes out of the air handling unit and supplies air to each of the spaces. Return ducts are just like your house, where the air is returned through. In the past, codes have said that you need them in both a duct smoke detector in the supply air and the return air. Then they moved to you only need it in the return air. And now I believe if it's over 20,000 CFM, you again need them in the supply and return. But for this unit, I checked into it again with our simplex guy, and I think you only need it in the return duct. Is that from your understanding?
In the past, sometimes we put one in the return, and sometimes we put one subliminal return just to be safe. It's not required by code, but just to be safe. But whatever you want them to do, I mean, it's ultimately you're going to end up with one or two.
Yeah.
Are you going to go through the duct heights and all this good stuff?
Yep. You don't have that handout that I've given out in the past with the 6 duct widths. I should have brought it myself, but I can go over that.
I can dig it, probably if I dig deep, I'll find it.
So a duct smoke detector is, can I draw on this whiteboard here, Chip?
Yeah, why don't you I can get you a flat
Yeah.
view here.
If you
Yeah,
want me to do
absolutely.
that,
Let me
that's
just
fine,
take
too.
a snapshot of this. That'll be easier for you.
A duct smoke detector is a little bit different than a regular smoke detector. Essentially, it's a regular smoke detector with a special housing on it.
And if you
Sense
want
the
to
smoke.
return to this view, you can always draw on that one. So here's a flat view for you. You can use one of those.
Well, let's see here. A duct smoke detector. I'm just going to draw just a. Here's your return duct. So return air heading back that way. A duct smoke detector is all it is a housing that mounts to the side of the duct that's sealed completely, and inside that housing it has a little smoke detector here, which is just like a standard smoke detector except it's inside this housing, and then there's sampling tubes, which is basically just like a stick of EMT conduit with holes in it. So there's two sampling tubes. Let's see if I can get a little bit. This big marker is kind of crude here, but it's imagine a stick of EMT conduit, and then with just some 1/4-inch holes drilled into that conduit. So the return air is coming back here, but there's smoke coming back here, and it slowly comes into here and goes into these sampling tubes, which is continuously taking a sample of that air that's coming back through that return duct. It goes into this sampling tube. This regular smoke detector senses that because the sampling tubes go into the smoke detector and take a sample of that air, and then that sends the alarm back to the fire alarm system that says this unit, duct smoke detector, has smoke inside the return duct. And what it's supposed to do then is not only does it send an alarm to the fire alarm system that says there's smoke, it shuts that air handling unit down. So there's relays that are programmed into the starter of that air handling unit that completely shut that air handling unit down. So now this return air isn't being distributed throughout the building or distributed into wherever you return. It might come back into the mechanical room. So the return on that, basically the smoke won't be blown throughout the entire building. It'll shut that air handler down, and so that alleviates that. I guess let's go back to the floor plan. So for this specific air handling unit, we have supply air ducts going out into this space. We have supply air ducts going out into this space. And then we have return air, which there's different types of systems. There's ducted return, and there's return air plenums. So the return air sometimes is just above the ceiling. They use the entire ceiling space as your return air duct. So imagine the entire ceiling space. You pop this tile. That's all your return air space. It all eventually gets back to the air handling unit. And then there's ducted returns, which they actually have ducts that run throughout the space that bring air through and direct it back to the ceiling space, or back to the air handling unit. This specific building has a plenum return. So there is a return duct, but essentially all it does is come off of the air handling unit and basically just punch into this corridor right here. And then there's ceiling space throughout the entire space. So you pop your head up above a tile, and you can see the entire space. The walls don't go completely up the deck. The walls only go up a little bit past the ceiling, so it's the entire above the ceiling is the return air plenum. So the only the only return duct that you have for this unit is in the mechanical room. So we're going to require a duct smoke detector on the return air only. I'm going to make an executive decision. And so you need one duct smoke detector, and it's going to be basically, yep, if you want to draw it in there, yours will be better than mine. In the return duct of the unit inside the mechanical room.
Everybody got that one on there, the duct smoke detector, just one in the mechanical room. Most of the time we have the mechanical layout and then you know exactly where that's gonna be located.
Yeah,
with coordination with the mechanical guys.
Yep. Yeah, most of the time you would work with your mechanical engineer and ask them where the smoke detector should go. I'm just going to kind of use, if we were required to put them in the supply air duct of this particular building, they want it to be, and even for this one, even for this unit, they recommend, so Simplex, Silent Night, whoever system you have, they recommend that you put the duct smoke detector 6 duct widths away from the unit. What that means is if your duct is 12 inches wide, then they want that duct smoke detector to be 6 feet, because 12 inches times 6, or 1 foot times 6 is 6 feet. So they want that. So if this duct is 12 inches wide, then they want the duct smoke detector to be 6 duct widths away from that unit. The reason for that is to prevent false alarms. Air tends to be a little bit dirtier when it gets closer to the unit, but the filters tend to work that out. So that's kind of their reasoning for that. For this particular design, you don't really need to worry about that, but I want to make sure you're aware of that, because the return duct is only in the mechanical room, and depending on where it actually is, you might not actually even be able to get 6 duct widths away from that unit. But you need to keep that in mind, and again, it's only a recommendation that is recommended by the manufacturer. It's not a code. So no, it's on any duct. So if this was, I don't want to get too far into it, but if this was a ducted return, so there was return ducts that came throughout and went throughout this entire space, then you would want to get 6 duct widths away from that air handling unit, because there's more space to deal with. Right now, all you have is this little chunk of duct that's going into the ceiling space in the corridor. I'm not even sure if you have 6 feet. In fact, I know realistically what we have, we don't. Because realistically, instead of coming out the back and kind of punching into the corridor, it basically just punches through right there. I mean, it's probably that long. So you can't get 6 feet away from that. It's just not possible. So, but again, that's not really something you need as part of the design of this project, but it's just something you should be aware of. So duct smoke detectors are a little bit complicated sometimes, but the moral of the story is that you need one of them, and it's in the mechanical room. So
is that 9 feet of duct? In other words, if it comes into the top and it has to hit the floor, most of these things come in with that one.
yeah, it's after any turn. So a straight chunk of 6 feet. Yeah.
Okay.
Yeah. All right. Connection, number 8. Connection to fire protection system devices as follows. 2 tamper switches and 1 flow switch. This is the connection to the fire sprinkler system. which the fire sprinkler system for this building is gonna be,
Just put the marker down and pick it up again.
oh,
Yeah. Don't ask me why. No. We're good.
get rid of that.
I have to do it again. Okay. You have to do what you did again.
Alright. So the main, where the water comes into the building for the sprinkler system of this particular building is gonna be basically in this corner of the mechanical room. So there's a fire protection assembly for this building. It's where the water comes in, and it splits. Either it goes to the domestic water, to your faucets and your toilets and everything, or it goes to the sprinkler piping, which is for fire protection. So it says here that we have, and this is another thing that you would coordinate with your mechanical engineer. So it says here that you have you have 2 tamper switches and 1 flow switch. I'll start with the flow switch. A flow switch is, there's probably either 1 or 2 zones for this building. Zones being there's sprinkler piping going out here and distributing to this area, and maybe that's 1 zone, and then there's a zone here going out to this area of the building. We asked for 1 flow switch, so I would assume that it's actually probably 1 big zone, and it probably, let's do this over again. So let's say it's 1 zone, and it basically splits off. So it feeds that end of the building, that end of the building. So there's a pipe coming up into the higher part of the mechanical room, and then it goes out and it feeds all of the sprinklers throughout the building. We want to know when a sprinkler head out here, sprinkler heads are just like smoke heat detectors, in that they actually have a little what is it? It's like an element, or help me out here, Chad.
It melts with heat.
Yeah, it melts with heat, and so when a sprinkler head goes off, there's really no smarts to it, but when that little element melts, it knows that it needs to spread water out in that space. So if there's a fire in this area and that sprinkler head goes, the element melts in it, then water will start flowing to this area. And when water flows, we want our fire alarm system to know that. So there's a switch on that pipe that says, when water flows, I want to send a signal back to my fire alarm system. So there's a flow switch that, I put DS, but anyways. There's a flow switch that tells the fire alarm system that the sprinkler system is going. So, because the sprinkler system might know there's a fire before your fire alarm system knows, because we have smoke detectors, and essentially a sprinkler is a heat detector. It might know that there's a fire, that there's a high flame fire before there's any smoke that can even reach one of the smoke detectors. So it's another way of getting a signal to that fire alarm system that there is a fire in the building. A tamper switch, there is, we asked for 2 of them. There's gate valves. Picture just a big wheel on the sides of your fire protection assembly. There's gate valves that you can completely shut off your system. Your fire protection system is shut off. The water will not flow to any of the sprinkler heads if you close this gate valve. If that happens, you want to know that happens, especially if, I don't know, if somebody comes in to do work on your fire protection system and shuts the gate valve and leaves it shut, then you want your fire alarm system to know that gate valve is shut, because all of a sudden, if there's a fire, the water can't flow to the sprinkler heads. So a tamper switch tells the fire alarm panel that those gate valves are shut. So water cannot flow to the sprinkler heads. So we asked for 2 of those. 2 tamper switches and 1 flow switch. And then number 9, connection to fire protection horn strobe located above the signees connection on the exterior of the building adjacent to mechanical 116. So signees connection, I'll start there. On the outside of the building, there is and I'm just going to draw it real large here so you can see it, a place for the fire department to hook up their hoses to tap off of the water for your building. So the fire department pulls up, they see the building's in flames, or they get an alarm, they know it's in flames somewhere. They can pull up and drag their hoses over to this specific connection, the signees connection. They can connect their hoses up there, and now they're using the water that's supplied to your building. So that's called the signees connection. The reason for having a fire protection horn strobe located above that is so they know where to go. They drive up to your building. They might never have been to your building before, but if they see a big horn strobe flashing on the outside of the building, they're going to know to go there because that's where the signees connection is. So when you specify that, you got to make sure obviously it's not one that you put inside of a classroom. It's a weatherproof one because it's on the outside of the building. So it needs to be able to handle the elements.
So do they have I don't know much about fire code. They have to have a backup system, from the street, fire hydrant, right?
Yes. Yeah.
Because you can't rely on that.
You can't rely on that.
What if the fire's back there?
Yep.
I'm wondering about that. Both make sense. One, the description I'm reading and looking at them says it's for the fire department to augment your sprinkler supply. In other words, they're pushing water into it, not taking water out of it. And then on the other hand, it would make sense to have a handy place to connect.
Well, that's
So I just
That's
kind
what I
of want to know
thought
which
too.
is which. That's what I would call a fire department.
that's a good question. If you figure it out, let me know.
The number.
Whatever the situation is, we need the horn strobe right
Yes.
in there. So.
Yeah.
But I was thinking the same thing, Chris.
See here pretty fast.
Is either push the water in or take the water out.
Yeah.
And maybe they do both. That's a good question we have just Eldrick here, he deals with the fire. We'll ask him today.
Yeah.
'Cause we deal with the fire at Dunwoody all the time with the fire
Yeah,
department.
that's a very good point, and I might be understanding it completely wrong.
And then I think it's probably both ways.
So that's kind of fire alarm system. Is there any questions on that for this building? Technology system. I'm not going to talk too much about that. I'll say the point again that we call it out here in the specifications as 1.17 technology raceway system, because the way we used to do it is the electrical contractor would put the rough in for the technology raceway. He would put an empty back box and a conduit going up into the ceiling in each wall right next to each computer location, and he'd throw a pull string in that conduit, and then the owner would, after the building was built, the owner would hire his own data guy to come in and pull low voltage cabling for all of the computer outlets for this building. That's not what we're doing on this project. You guys are kind of showing every location where we have a phone line, a voice line, and where we have a data line. So, and it kind of goes through the specifics on where the owner wants every device. I think it's pretty clear there. says we want Cat 5e voice cables, Cat 5e data cables. That's a specific type of cabling that we want. Is there anything else you want me to touch on that, Chad?
I think that one is clear, right, guys? Where you need your phone data. The only thing I want to mention is when you deal with Revit, I can say it's phone data. There's a family for the phone, a family for the data, and also a family for a combo phone data. You know, and we just throw them on the walls, and you know, just to get into the habit of throwing them as a families.
Yep.
We don't circuit them. We just throw them. We don't even zone them or.
A good habit to get into maybe, and you could probably take care of it with a keynote, or if you were issuing a spec on this project, is data cabling. All, you know, with laying ceilings like this, some data guys will come in and they'll just throw their cable above the ceiling and won't support it at all. Obviously we don't want that, so you might want to say something about supporting the cable, whether it's J-hooks or a cable tray or whatever, but something to support it, so when you go and pop a ceiling tile, there's not spaghetti all across the inside of your or above your ceiling tile. So that's just something that you can take care of, as simple as a keynote explaining what you want to the contractor that's bidding the project, explaining that he should put a J-hook every 5 feet to support data cables, or he should tie wrap it to the joists above, or just something to get it supported. So
Just to support with what you said, Joe, in the article that talks about communication too, the code requires them, so you can hold it by code to support their cables right now, and
Some of
to
them
do them
still
in a
don't.
workmanlike manner. But absolutely right. But as an engineer, it's a very good idea to add it too.
Yeah.
So
especially a lot of
accountable.
these,
they're not used to adhering to the code.
yeah,
They're not. They're just not used to.
a lot of these companies, and even I'll always use the example of schools because I've done a million of them, but they hire their own, so they have their own technology guy, their own IT guy, each school does, on staff. So we do a little remodel where we add 3 classrooms to a building, and they might just say, we're going to have our guy do that, and he'll go and he'll do it, and he'll get everything working and everything will work fine, but you know, he doesn't, no one's inspecting his work. So you go up above the ceiling and it's just thrown above the ceiling tile. So yeah.
Is there any interference that you worry about with like data running next to bringing a power connection?
Yeah, you shouldn't. I know a few things, and I don't deal a lot with low voltage, but I know like for supporting, a lot of guys like to support off of electrical conduit. So you have a branch circuit, you know, that's got number 12 wire in it, and it's running. It's through, yep, where they'll tie wrap to the conduit. I know you can get interference that way. Most data guys know that. Not all of them might, but again, it's something to keep in mind. And where we would do that in our jobs is in the specification, because along with drawings to each job we issue a specification, a booklet that says all of the really, really in-depth details, that says the common sense stuff to you and me, but not every contractor might know that. And it'll specify that you can't support to low voltage or medium high voltage, whatever you want to call it, medium or high voltage conduit. So. Anything else?
Thank you, Joe.
Yeah.
Anything else guys about low voltage? We have security, we have phone data, we have a TV, which is easy, just one outlet,
Yep.
and we have the fire alarm system. So just FYI guys, because what I like about the industry speakers, Joe, that they always talk about the technologies. There's so many technologies of smoke detectors. And I think next project we will be inviting a speaker just to talk about the different technologies that he uses smoke detectors.
Yep.
So if you're wondering what type of technology they use in smoke detectors, in an industrial project we do have a speaker that talks about specifically the technology. Yeah. Can't remember. I think Simplex came
Really?
in the past. Yeah.
Okay.
Or if not, Silent Nights.
Yeah.
So it's really nice to talk about just the different technologies of smoke detectors and so forth. Like lighting control panels and occupancy sensors. Great speaker about the different technologies. You guys remember how we talked about the technology that they use in them, the eyes and the ears and so forth?
Yep.
They do the same thing. So I thought that was really nice just to know. So.
Yep. There's a lot of different types of smoke detectors out there. So.
Thank you. Any question, guys, for Joe? Anybody has any question for Joe?
I know you got Revit questions. I've been talking too much. How about for Nick?
So we'll oops, excuse me. Cancel. Okay. Any question, guys, about low voltage design? I think the design is clear. And for the Revit, we have Joe here. Joe. We have Nick here. I think I'm not losing it. We have Nick here that can help you guys with any Revit issues. Doesn't have to be low voltage. I know they haven't started the low voltage yet. But if you guys have any questions, I want to remind you two things, guys, for the low voltage, and Nick is here, so he can tell you otherwise. When you place your devices, you're going to place them in this plan. We call them the floor plan systems. All the devices in the walls, we're going to throw them right in there. Anything in the ceiling, what we have done in the past, and you can correct me here if I'm wrong, Nick, my friend. What we've done is we went to the ceiling, and is this my ceiling that has? Okay, no, this is my ceiling. I just turned the grid off. So we went to the ceiling, guys. If you have anything that's going to be in the ceiling, you're going to be in this view, and we use this view for you guys. You use it for lights. So put them right with lights. Don't worry, because when we VB them, they're not going to show up. The lights is not going to show up. So what we've done in the past, anything in the ceiling, we put them in the ceiling view. Anything in the walls that's going to be installed in the walls, we put them in another view. Does that make sense, guys? For families, just if you guys, Nick, you, as long as you're here, for families, because that's what I invite them to do, there are two locations for the families I'm going to use. I want you guys to be aware of it because I'm going to do advising after that. I'm not going to be with you. So when you go, you're going to go insert the first one. And thanks to Nick and all our friends, guys, we developed a couple of, go to the instructor folder and to Revit and 2011. And we have a folder that has almost all the families that you want. So if you click, the first thing you need to do when you load them, you need to go to all these door contacts, duct smoke detectors, fire alarm exterior tags, also tags. Make sure before you start doing anything, go to that location and load all the families into your project. Can I have thumbs up that you guys know how to load that one? Okay, I did load them myself. Thumbs up. The second thing you need to do, so this is the first stop you're gonna go. The second thing I suggest to go is to go again, load again, and go to the stuff that came. This is from, this is the library that came with the software. And you guys are familiar with this. You're gonna go to electrical components in your C drive, and to find the low voltage stuff and the fire alarm system, you go to your C drive, electrical components, and then if you go to information and communication, you're going to find fire alarm system, security system, and communication. These three folders are very, very important. You're going to have extra stuff. So how would I start? If I were you guys, I would start with the folder that we're giving you in the instructor. We start with the families in the instructor folder. If you couldn't find a family that works, because in the past we had some issues with the family. If the family doesn't work, if you can't get it to work and you need, or if it's not there, you go to the library that comes with the system. If you go to communication, for example, you find all these families that God created about communication. Communication here, guys, is the phone and the data. They call them communication here. So a couple of things here, buzzers. And if you go back, to fire alarm system, the same thing. Have a lot of stuff about fire alarm system, horns, strobes, speakers, you name it. A lot of stuff. And the last thing is security system. Security, they have card readers, electric lock, key card might be a good security alarm, and security siren. Okay, so your first stop is going to be the instructor folder. Second, you're going to go there, dig and find, and see if you're missing something, go there and dig to find it. Can I have thumbs up that we got it, Chad? And just stop talking. Okay. All right. So with this, I'm going to let you guys with Nick. If you have any question, Chris, what was your question yesterday? You had something not related to Revit. You had something about design. And I told you to hold it in your brain. Now, when they leave, you ask me the hard ones.
I gotta wait.
There was
wait for them to leave.
no, there was something. I can't remember. It's not Revit related, but anyway, if you guys have any question where we are right now, we redlined the lights. If you guys want to look at it in the back, I think they did a great job. We're still missing notes and keynotes and all the stuff. That's what we're going to be. We're mostly interested in laying out the fixtures and circuiting right now. And later on, only the A and the A plus, I'm going to be asking him guys to add notes. The D and the D minus, you know, we can live without notes. So that's how. So we're going to be adding notes. The only thing that's not added right now is notes. But we redlined for them. I think they did a great job in laying out the fixtures and with the help of you guys, and especially with the ceiling. The ceiling make a major difference. Thank you. I mean, what we were missing is the ceiling. I think, right, Chris, when we brought the ceiling, things went much smoother. We talked about secure egress lights and exit signs, and we walked them through how to place them too. And if you want to say a few things about this, Joe, about egress lights and exit, what we're using right now is bug eyes.
Yep.
Though we have a generator, we're backing up the building with a gen. We're not assuming that this gen is an emergency, meaning we're not requiring to come up within 10 seconds. So that's why we're backing it up with bug eyes everywhere, basically. I don't know if you know, say a few things about.
Bug eyes are meant to get you out of the building. They have batteries in them that will last 90 minutes. I guess just look at it from a standpoint of you're trying to get out of that building with no lights when you're laying them out. So you need to get a path of egress. And also, you should be able to see an exit sign wherever you're standing in that building also, to see the closest exit. So.
No, this doesn't, private offices and stuff.
No, private offices, yep, you should be able to walk out into a common space and see an exit sign. Yep.
Is your ceiling grid 2x2 or 2x4?
2x2.
And are you seeing commonly 2x2 light fixtures now, or is it still?
No, 2x4 light fixtures, 2x2 ceiling. 2x2 ceiling, you don't get the tiles sagging.
Like here.
Yeah, like here. And 2x4 light fixtures, a 4-foot lamp versus a 2-foot lamp usually has a little bit versus a little bit more output and a longer lamp life even for those lamps. So we try to stick with the 2x4 fixtures.
Yeah, I would imagine this 2x2 is more expensive. Just
Yep.
a new shape.
Yep. Less common means more expensive. Yep.
And we took the executive decisions and we made the egress path because we're all the architects. What I told them is to have this one right in here. This is my egress path. I'm just going to draw that one. And we took another egress path right here, egress path right here, coming out of here to get out. And then we went all the way to here, out. And so we need to let this area, and we went through right into here. And that's our egress path, guys, that we decided, if you remember. And we said we're going to put light, the bug eyes, to lit this area. I'm just showing that one, Joe, to pick your brain. That's what we picked. I don't know if we should pick that one, that other end or not. But
ours is almost the exact same, except we don't send people through the receiving room.
Okay, the
So
receiving area.
We send people to the main entrance
To the main
or
entrance.
to the lunchroom
Okay.
exit.
And this, guys, will decide where you're going to bring the bug eyes over here. You're going to be replacing probably, we talked to the people, you might have to put 2 bug eyes. I know I redlined with you where we're going to put them for the most part. And I think, aren't they 25 on center or something like this?
Yeah,
or
25 to 30 on center.
25 to 30 on center. So this is where you're going to be able to lit that area with the bug eyes. So areas and so forth. And I know you guys, when we redline them. And exit signs, obviously, we place all our exit signs on the exit. We just made the executive decision, and then we place them a couple of places here to direct the traffic. I think we.
You also have to be able to. You
Are we missing
If
anything?
you're using this as an exit and that as an exit, you have to be able to see
Yeah.
that exit. So those are enclosed, closed rooms. So to get to those, you have
Yeah.
to see an exit. Yep.
Yeah, right to the top of them. That's what we, for the most part, did. Anything you can add to, Nick or Joe? I don't know.
No, I think
That's just for the emergency light and exit signs. And we're using bug eyes.
Yep.
The question came is how often, Nick, you asked that one, how often you use a fixture like this with battery backup versus bug eyes when you guys see it?
Architects like it because then you don't have a bug eye sitting on the wall. They work the same and they last about the same amount of time, but a lot of times they get forgotten. So because you don't see it, you don't physically see it. The bug eyes, they're nice because you can see it. You can see that you walk by that LED and it's flashing that the battery's dead. Then you as a custodian, a building engineer, you know to replace that. Some of the battery ballasts, they have that same LED, but it's just it's so hidden away that they get forgotten about. We find so it depends on the project, but we do use them. Yeah.
Do you commonly use battery backup or generator backup? Like if you have a generator within 10 seconds, when you guys are doing school, there's not a whole lot of
If
generators.
it's a brand new building, we usually use generators.
And then you use just one fixture used for emergency and normal?
Yes,
With
and
that
then we put
relay?
a switching relay. Yep.
Okay.
So you don't even know. You walk into a classroom and you can switch on and off the lights. You don't even know which fixture is emergency.
Yeah.
But there's a relay up in the ceiling that says that when we lose power, that's my emergency fixture and it's going to fail on. So even if the lights are off in that room, that fixture will come on when the generator comes on. So.
Does that just fail over to a separate UPS powered circuit or generator powered circuit?
Yes.
Or does it-
Yes.
And I think, Nick, even if you lose the power, if the circuit breaker that feed the classroom is off too, it will, somebody go turn the circuit breaker off, saying Nick or Joe. If somebody's going to turn the circuit breaker off in this room, that light will go on, right?
Yes.
Yeah. So they have a sensing
Essentially,
mechanism,
yep.
and that's what we're going to be doing next project too,
Yep.
is to put that little relay with an emergency panel backed up by generator. So. But I thought this is the first time we ever done bug eyes in the project, which I thought it would be really nice to introduce them.
Yeah, they're
to the
I
whole
mean, they're
bug eye.
commonly used out there because they're cheap mainly. They're a lot cheaper than a generator to maintain
To
and
meet
everything.
the
So
code. Any question, guys? Anybody has any question? Revit questions? Now Nick leaves here, and you guys start asking me all these hard questions. There was a design issue though. Gosh, I can't remember. Okay. Yes, loading your families. Okay. Okay. Thank you, guys.